Well, good morning, everyone. Welcome to Tech Talk with Dave. Today, I'm going to continue the series that I started a couple of months ago on Cambium's cnWave product. But today, we're going to not talk about the product directly. We're going to talk about planning for a network with the product. So, what I want to talk about today is actually in LinkPlanner. And there's a few features in LinkPlanner that are kind of unknown to many people, and I hope that I can shed some light on them today and make your life a little bit easier as you're thinking about whether you want to use this 60 gigahertz stuff or not. So well, with that, this is what I intend to cover in the next 58 minutes or thereabouts. We're going to do a short LinkPlanner overview with a live demo. This is I've only got a couple of slides here to go over. There's some things that I just want to reiterate. We're going to go over the steps to generate a project. We're going to import some network sites. We're going to import some subscriber sites. We're going to build some hubs. We're going to build some templates. We're going to do a best serving sector analysis for connecting the subscribers, because in a case of a mesh network, it's really important that if there's two or three choices that a connection node has to join a distribution node, it's important that we pick the best one. So that's the way to do it here in LinkPlanner without guesswork. Takes the guesswork right out of it. One thing that I do wish, and I'll say right up front here, is that LinkPlanner's clutter for most urban or suburban areas, places where you would typically use cnWave, is not very good. So we have to do these projects with the clutter turned off, and we'll see what that means here in a bit. But lots of times in a suburban area, you've got a group of houses, you got some trees, you got some other stuff in there, and the 30-meter clutter that's available for LinkPlanner, we'll call it all just one block of trees or one block of houses, and you won't actually see the difference between them. That's the difference between CN Heat and Advanced Network Planner for cnWave, which is kind of the next step. Takes quite a bit more input, but most of the time, when you're in the process of determining whether or not you can justify a cnWave project in a particular area, this is the what I'm going to go over today is the process of analysis that you probably should do, and then when at the end we're going to generate a bill of materials, and then you can take and of course get that priced out. We'd be happy to do that for you, and you can then make your own decision as to whether this network is for you, or you want to take and wait for provide fiber to the premise, or whatever it is that you're going to do with a particular area. All right. Now I just want to go over the interfaces that we have available on the cnWave. All right, so the V5000 and the V3000 are similar units in that they both have a 10 gig copper with a 10 gig PoE available for it. They have a 10 gig SFP plus, which can take a multi-mode or a single mode SFP module, and they all have a 1 gig auxiliary port. So we're gonna make use of this information as we're going forward here. When you see what we have to try to accomplish here. The V1000 now, the connection node, is I shouldn't say it. I shouldn't just call it a connection node, because they can be both a distribution node or a connection node. But the V1000 has a 1 gig copper with a PoE only output on it, so it's not quite as versatile as the V3000. All units can use the onboard or the external E2E controller, so we can turn it on. Even you want to create a point-to-point with a pair of V1000s, like that's what I have in my lab at the moment. It's got the onboard E2E controller working, and I just enabled it in one of the V1000s and turned on layer 2 tunneling, and away we go. All of the units can be either dedicated to the point of presence, the POP, or they can be non-POP nodes. So we have that choice with the entire product line here, all 3 units with cnWave. So this makes it extremely versatile, and that versatility can be, of course, it can be a help or it can be a hindrance, because the rules, depending on what you're doing, can be actually quite different. So here we go with the link combinations that we can possibly do. All right, so the natural arrangement here would be a V5000 as a distribution node, and V1000s or V3000s. I see my graphic slipped. Anyway, the V3000s or the V1000s can be the connection nodes to that. That's the natural multi-point method of connecting the radios together. Then, of course, we have the mesh is created by linking V5000 sectors to other V5000 sectors, and with those we have either a 1 gig or a 10 gig interface, depending on what you want to use, of course, like as we talked about just a second ago. And then finally, there's the E2E controllers can manage the back-to-back link that's in the when if we have to reach a distance with a V3000, for example. Let's say we have to go 300 or 400 meters instead of just we'll see the ranges in a second here. If we have to go farther, we can use V3000s as a connection node and then have that connected to another V5000 to continue on with the mesh, and we can manage that connection between the V3000 and the V5000 in the E2E controller, as well as the, of course, connection to the original V5000. When it comes to point-to-points, we have a couple of choices. We have the V1000s that can be linked together, and the V3000s, of course, can be linked together. The advantage of the 3000s is the higher gain antenna, the 44 dBi gain antenna. So our link distance, let's talk about that for just a half a second here. One more thing, the GPS, the V1000 unit does not have a GPS input. So therefore, when we build a point-to-point out of the V1000s, we have to channel plan them out of the way of the rest of the network. The V3000s and the V5000s all have GPS receivers built into the antennas, and so they can be synchronized. And so we can take a V3000 point-to-point and incorporate it into the mesh. And from an RF perspective, we can then keep our self-interference very, very low. We'll talk a little bit more about that another time. I don't want to really get into that because that'll take a way bigger bite into things than what I had originally intended for our tech talk today to be. So for another day. All right, the typical cnWave range matrix. All the links, these distances are line of sight, typical range zones here in Canada. The range values are typical over flat terrain, and elevation and azimuth of the devices is very important. We'll see that as we get playing a little bit inside a LinkPlanner, but from a deployment perspective, you really don't want to have say a V5000 at 40 meters above the ground, and then you've got V1000s at 10 meters above the ground, or that kind of thing. You want to take and try to maintain the same elevation for the entire network. Just a little tip there. So 5,000 to 5,000, about 150 meters. 5,000 to V3000, we can go about 450 meters, give or take. V5000 to V1000 is about 150 meters as well. In some cases, you can stretch it out to 200, but we're going to go through the scenario that we're going to go through today. In the area that it is, you're going to see that that 200 meters is too far for for 5,000 to 5,000 mesh connection. V3000s connected to each other in a point-to-point fashion, we can get about 1 kilometer out of that, maybe even a little bit more, depending on what data rate you're going to allow through the network. And V1000 to V1000, about 150 meters. Now, these distances that I've got quoted here are for good performance. So we're talking, more than a gig across the RF of the link, so that at least with the gigi connectors on the V1000s, that we're going to, more or less fill up the Ethernet interface. All right. So here's what we're going to go through for the rest of our time here. We're going to go through this preparation. Some of the things here I've already done, and in order to save time, because some of this, of course, can take much more than what we have in an hour here on Tech Talk with Dave. So the LinkPlanner preparation process should look like this. We should create a KMZ file. Google Earth is the best. I like when things are visual. The more visual your planning information, the easier it will be to use and analyze and adapt and whatever you need to do with it. So you create a KMZ file with potential DN locations plotted. Make note of which ones are going to be the POP locations if they're DN locations. If not, if a POP location is not in the network, then make note of where it is so that we can create a point-to-point to get to it. And then secondly, you create a KMZ file with pins on each possible subscriber location. If you're doing a network that already exists, of course, the pins on the existing subscriber location, so that you can take and create links from the DNs to the CNs. Subscriber data that is generated from GIS information may put the lat and long at the street edge, at the mailbox in some parts of our country, or simply located in the middle of the street. So ensure that the pin that when you import that data and you create your KMZ, or you create your CSV file that you're going to import into LinkPlanner, ensure that the lat and long point is actually on the building or the structure. This also, if you're going to take this to the next level, this process is very important to import our data into Advanced Network Planner if we're going to take it to the next level with LiDAR data and the level of complexity. This is the place to begin with, is to have good data with your DN locations, your possible DN locations, as well as your possible subscriber locations plotted. And of course,
I'm so sorry, Dave. Do you mind going back to the last slide? We just have a quick question, and I'm so sorry, I thought you were at the last point. So for Eldon would like to know, what channels are you using for the distances you're showing?
Channel 1, the worst. That's the worst channel. Channel 4 will be better.
Great, thank you.
Okay. And channel 2, by the way, with the cnWave product, channel 2 is the factory default. So it'll all come out on channel 2. So the oxygen absorption on channel 1, 2 are similar. 3 is a little bit less. 4 is quite a bit less. So we start to move out of the band. But when you have 2 gigahertz channels, you've moved quite a distance actually in spectrum from 1 through 4. So the worst is right at 60 gigahertz. So the band right there is the highest oxygen absorption. So that's where my numbers come from. My guesstimate numbers. You could argue with me that it's 155 or 175 or whatever, but you won't get very far, because I'll just shrug my shoulders and say, okay. All right. Now, I think we covered this. We'll go to the LinkPlanner demo. Here's what we're going to accomplish in the LinkPlanner demo. I'm going to import some DN locations from a project that we already have, I've got two LinkPlanner projects that I've created. One I've done all the work for the area of the town that I'm working in. So I've created a project that I think should work. But we're going to take and we're going to do a blank project today. We're going to take and we're going to import some DN locations into the project. We're going to import some customer locations, some CN locations into the project. We are going to create a point-to-multipoint and a point-to-point template. This is, I think this is a very important part of the project, because now when I go to add a link, it's going to use the PMP, or it's going to use the PTP template, depending on what I'm actually adding. If I'm adding hubs, the point-to-multipoint. If I'm adding a link between a couple of DN locations, then the point-to-point template. We're going to take and add hubs to the DN locations, again, using the template. We're going to create mesh links. We're going to spend a fair bit of time at this, because there's a bunch of things I want to show in creating these mesh links, and then adding point-to-point links if it's necessary to connect the DN locations. I'm a big fan of making sure that the network is performing at its highest level. There's so many things that can go and decrease our link quality, heavy rain, all sorts of things that can affect the link. So if we start off with a link running at a bare minimum, then we have no place to go when fading comes. So I want to, from a planning perspective, I want to make sure that the links are created as good as possible. So therefore, we are going to take and use V3000 point-to-point links where there's no mesh connection between V5000s. We can manage this in the EDE controller, because as I mentioned, we can take and call a wired link between the 5000 and the 3000 that we're going to connect to the next site, and the same thing. And there, it's going to make for a bit of a complicated network. However, it's going to perform and do exactly what it's supposed to do when we're finished with this. So we're going to have a working network that you could go out and deploy. And then finally, the last thing is we're going to run the best serving sector module to add some CN connections to the DN. This is, as I mentioned before, this is really important because if the network is done correctly, then we're going to have situations where CNs are definitely going to have more than one DN that they can connect to. And we want to take and use LinkPlanner to analyze what's the best. Our eyes sometimes, we look at a map and the map will make sense, but there's some things that may limit what the connection, the DN-CN connection can do by azimuths of the DN, by you know, a number of things. Terrain can make a difference, so that would be the elevation between the CN and the DN, that kind of stuff. As well, the best serving sector module, we can take and select both V1000s and V3000s to analyze when we build this network. So then, if a location needs to connect with a V3000, if that's going to be the best quality link, then it's going to recommend a V3000 at that point. If a V1000 is going to create the best possible link, then it's going to recommend a V1000. And this module, I've done quite a bit of testing with it. And this best serving sector module in LinkPlanner works very good, actually. So it's kind of impressive. I have some other software that I normally use that does this very same thing, which you know, costed the order of 50 grand or so when it was new a few years ago. And of course, it does best serving sector very, very well. But you know, for the price we pay for LinkPlanner, it has some amazing features. All right. So here we are. We got my blank project. Okay. Just as a bit of a teaser, that's kind of where it's going to end up. Is that we've got CN locations, we've got some point-to-point links, we've got some mesh links in between the distribution nodes, and of course, then we've got connections to the customers. Some of them are V3000s, like Ones over here will be a V3000 quite likely, and some in close will be V1000s. So we're going to have a network plan by the end of this. So let's go back to my blank canvas. Okay. So here in my blank canvas, we're going to do a couple things first. Let's first import the network sites. I have them in a CSV file rather than a KMZ file because I did a little bit of massage on them. So I'm gonna take and go here. So I've got a DN shortlist. We're going to import that one, and there they are. So I'm going to go through, and I got to make sure that the labels are correct. So this one is not the name, it's actually longitude. And the one that's longitude, I want to call it the name so that I have it right. So all the red went away. It's good to go. Here we are. All right, so I'm going to plot them. I'm going to finish. Boom, there we are. Beautiful. There's my possible DN locations. Now, I think that there's two ways that that networks can be planned when we're doing cnWave. One of them would be to put the DNs at exactly the right location. That would mean that we have to take and actually provide our own structures for this, or and I think that's going to be a lot less possible or even probable to do than what we take with existing structures like street lights on the poles. So we've been talking with a few operators that are doing this, and the utility company will say that, yeah, you can use this pole, you can use this one, but you can't use these two, or you can't use these three, or here's the list of what you can do and here's what you can't do. So you end up plotting the DN locations on the lamp posts that you can use. So are they in the ideal spots? Probably not. Some of them might be, but probably not. All right, so but this is what we have. Well, the important part of planning is to take what we have and make use of it. Now let's take one more thing. Let's import our subscriber locations. All right, so from CSV also, you notice probably in my file there's a subscriber shortlist. So there we are right there. And so again, I got the same three columns. So I'm going to take and turn the name into longitude. Latitude's good. And the name there, clear the errors, and I'm going to put it in there. They are, and boom, we have our customers. So I imported a few more distribution nodes than what I have customers. So I'm probably not going to use these. I would bet not. So at any rate, let's kind of center this in the middle here and blow it up a little bit. Beautiful. There we are. Next step that we're going to do is we're going to take and we're going to create some templates. So, whoops, wrong one. There, I already got this one. All right, there are no templates. No templates here in my Demo 2 project, which is the one that we're working on. So let's create a new template. Comes up, takes a minute, and I'm going to call it cnWave DN CN, just something to be descriptive. All right. So I'm going to go down and set some parameters here. So 60 gigahertz, it's going to take a minute. It's going to come up V5000 is my DN, and I want to use the FCC as country code. So there's my channel width to 2 gigahertz. My SM range, 2 kilometers too far. I don't want to do 2 kilometers. So I'm going to do, say, 300 meters as a maximum planning range here, because I could use some V3000s, but I'm mostly going to use V1000s, I'm sure, by the time that I'm finished. All right, so this is sector 1. So 3 kilometers. My number of registrations allowed, and I might build a mesh here. So I'm going to have to take a couple of these and, oops, come on. There we go. And use this so I can put 2 mesh links, which is the maximum that I can. So I can allow 13 CN registrations per sector. All right, so let's do the same thing down here, 0.3. So it changed already. and we'll go to 13, just like that, and away we go. So my model beam width per AP is going to be 280 degrees, 2 sectors split at 140 per sector. My ERP is 38 dBm, which is the legal limit here in North America. I am not going to count interference in here because I shouldn't have any interference, and it's quite unlikely. And I'm going to use the V1000 as my primary connection node module. And my maximum modulation is going to be MCS 10, which is the full smoke. All right. In my performance that I'm going to expect, you notice here that it's at MCS 2 is the default here. So that's BPSK. So it's taken the signal down a very long way. I want to do better than that. We want to take and run, let's say, at least 500 megabits through this system all the time. So I'm going to raise this up to MCS 6 at QPSK at 99% availability. Because the system does retransmissions, I can take and use 99%. If this were a typical microwave system with no retransmissions, I would put it at least at 99.9 or maybe even 4/9 of availability. But because we're using a system that has retransmissions, we're good here. All right. If I had some extras, say I wanted to incorporate a TX 2016 or a 2020 at each site to power the V5000, I could do that. I'm going to use the 10 gig SFP, I mean not SFP, the 10 gig PoE module in my little pretend network here. So I'm not going to take and add anything else to either the subscriber module or the access point. So that's essentially a template. All right, I can just close this because it saved this as I was going. So I can close this, and there's my point to multipoint template. Now I can take and create another one for any point-to-point link that I want to take and build. And it's essentially the same process. So I'm going to call it V3000 P2P is going to be my point-to-point here. All right, let's, whoops, come on. Let's set this up to 60 gig. It's going to come around and it's going to tell me the V5000 is the default. I don't want to do point-to-points with a V5000. That would be kind of silly. So select V3000s and let us select the North American regulatory filter. All right. So V5000, 60 dBm. Very, very good. We're going to leave the GOLE and the polarities all automatic for now, for the planning process. We'll get into the channel planning and that on another day, but I think this is going to take the rest of the half hour. All right. So my mean IP that I require in the link, we're going to make sure that these links are all really, really good. But I would say that the minimum I want across my link would be the average. It would be 1 gig, and my minimum, let's say, is 500 meg. I can do that in both directions. 1 gig. Oops. Hit a 5. There we go, Dave. Very, very good. Now I'm going to reduce the availability from 99.9 to 3/9 for this. Our links are all going to be short enough that it really isn't going to matter. But just for the sake of our plan at this moment, let's use 3/9 as our availability for here. We're not going to add any extras again with this as well. So that's our template. We have our template done. Perfect. Okay. So now we have our network sites. We have our subscriber sites. So we're going to take and we're going to add some hubs. That's our little new hub button up here. So if we go across the top here, if we're going to add a network site, of course, this is all should be review for most everybody that's familiar with Cambium stuff. New subscriber site, new point-to-point link, and a new hub. So the multi-point link is considered a hub. So let me click on new hub. All right, so it's going to give me the opportunity to put hubs at all of my DNs that I've selected here. I'm going to take and just use a few here around 28. DN number 28, let's assume, is going to be my point of presence. So let's go just down, let's just put in, say, maybe 4 at the moment. All right, and let's call them primary group, just for a name, primary 1, just for a name. So we got 1 AP per hub. My starting azimuth is going to be north, that's fine. And my separation angle is omni 360 degrees, and my range is 0.3 kilometers. So that'll be the initial setting for these units that I'm going to put in. So let's click OK. Let's go back to the map, and there we are. There's my DNs and their coverage areas. Of course, they all point north, so the nulls are all pointing south. And for most of the case, that's going to be okay. But what we need to do next is we need to take and build our mesh. We need to take and build these together. So notice in the project properties here, I have turned off clutter. I have made the minimum SM height as 10 meters, happens to be the default for all the rest of this. This is all assuming it's 30 feet in the air, 10 meters in the air. So whether or not that is the case, you would have done an initial site survey of the place, you'd be able to take and judge what that number actually is. So in my little pretend network here, we'll assume that we're 30 feet up is good. All right. All right, so let's take the display and let's turn the subscriber sites off just for a moment. Let's turn the access points off just for a moment. And our multi-point links, we don't have any at this moment, but we have links and mesh links and point-to-point links. Let's get that out of the way just for a second. We can turn that on. We can turn that on later. All right. When I click on a hub, so I go here to the hubs that I've got created. So DN28 here is my point of presence. This one right in the middle. So let me select that one. Let me go there, and it's going to come up, and it's going to show me what's going on with this. So there's my 13 CN registrations that are allowed. There's my azimuth of 0 degrees. I have no tilt on the antenna. My beam width is 280 degrees. I have no interference turned on, and so that's exactly what I put in my template. So I don't have to take, if I use the template, I do not have to take and check each hub that I put in. So the template's important. Now, when I go down here, you see there's this mesh links here. If I click on add a mesh link, look what comes up. Okay, so this is telling me all of the links that are within range, within this 300-meter range of DN28 in this particular case. So here I got DN25 at 105 meters, 27 is 134, and then 24 and 23. So let's just select one of these for now. Let's just select that one. So I click on it. I say, okay, I want to create a mesh link to there. All right. So the mesh comes up, and there it is. And it's black. If my mesh were not, if it were not possible to do, let's try another one. Let's go the long one here. All right. All right. So a mesh that has an issue shows up red in the table. If the mesh is okay, it's going to show up as black in the mesh link table. So here you can have a look and see what the reason is for this link to not be working properly. So if I hover over it, look at that. It says the reason for the error is reliability. So I have too much loss this 117 dB link loss is too much for a V5000 to V5000, but 110 dB is okay. And so then it calculates the availability. See, and I was asking for 99%. This is at 96%. So that's why this link is going to fail. If I look on a map, let's go back to the map. All right, so this DN25 here is okay. DN28 over here does not have a link to DN23. Now, this is suspiciously close to the edge of my sector. So let me just turn on the sectors for a moment. Okay, so there it is. So here's my sector. It's within the range that it is now. So this is just too far. So I'm not in the null. If I just for giggles here, let me spin this around. Let's change the azimuth here, and let's put DN25 firmly in the null of the and look what happened. Immediately DN25 went red, right? Because it's in the null pattern. There is reliability of my data rate. I can't make the data rate on the link, so therefore it fails. So this is why it's important to do the mesh creation. Let's go back to 300 and let's put it back north again just for giggles. There we are. Okay, so 290 that, and my DN25 link comes green again. Boy, there it is. So 23 doesn't work. So I might as well get rid of 23 right at this moment. So I can delete it. Yes, I want to remove that link. So don't want to consider it. All right, so let's go back to the project here. All right, so what else might work here? So 27 probably, was that one of the ones that let's just have another look. And so the DN27, 134 meters. Let's see if we got a link there. And why not? It says no. So why not? We have 1 gig. Link availability is high enough. Cover and see. So the reason is reliability. So it's saying that 134 meters, 112 dB. 112 dB is a bit too much. So the availability predicted 95% instead of 99%, and so that's it to accomplish these data rates. If I took and I dropped the data rate down to BPSK here in the modulation level, then it's probably going to work. But at the data rate that I want across that, I want at least a gigabit across that. It won't work. Okay. So let's have a look at this again. Let me turn off the access point so we clear up the display. So there it is. So at this particular moment, it looks like 25 might be the only one. Let's try 21. Let's go to 21. Let's see if 21 was a possibility too. 23, 24, 21 is not. So 21 does not work in there also. So, all right. So now I'm in a bit of a pickle. What am I going to do from here? So I started off. I can only get away from my my site. So let's get rid of this as a mesh link. It's not going to be good enough. All right. So what can I do? All right. So watch this. I'm going to take and go back to the map here. I'm going to take a point-to-point link. So I come up with my list of my DN to DNs. That's what I have plotted on the map right at this very moment. And I'm going to take a point-to-point link from DN. Let's start at DN28 and go to DN27, the one that doesn't work. So DN28 right there to DN27 right there. Press OK to create the link. And now because I've got a template, a 60 gig template in there, this is going to make the link out of V3000s. So here I'm going to have V3000 and it's black. So my link is good, of course. I have lots of signal for my link at that point. Let's go back to the map. And so I can see I've got a thin line, meaning mesh, from 28 to 25, but I got a thick line from 28 to 27, meaning point to point. So this is how I need to go about manually building this mesh. I don't know I've wrestled with this for a while. I don't know of an easier way to do that. So now I'm at 27 here. So I can go to 27. Let's click on 27. Let's repeat this process. All right, so I'm going to add a mesh. So my mesh to 24 is probably okay. My mesh to 26 is probably okay. So let's hold the shift key down and select two of those. Let's make two links at this moment. Let's see what happens. Both of those are good. All right. So now I've got a T at this moment. So there we have it. Now, can I go from 24 to 23? So let's go to 24. Let's turn up 24 here and add a mesh. And no, I cannot. I can't get to 23. Why? Well, it's because the azimuth of 24. 23 is in my null zone, right? So let's go back to the map. And let's turn on the access points again. There we go. And I'm going to select 24, which should be that guy right there. And I'm going to adjust the azimuth so that, which way shall I go? Go this way because he's on the outside edge of my coverage. So let's go like this. All right. So now I have a link. All right, let's turn that back off. So 24, those are all good. My links are all still good. So I'm going to go from 24 again to 23. There it is this time. And we'll take and we'll make the link. And bingo, there it is. So now I've taken and I've created that. I have a one point-to-point that I needed to take and go between the two sites. I could take and then mesh the three that are along the line there, and I would just keep on going for as far as I need to go in this particular case. So we've taken 10 minutes of time to do this. So my whole project here, if I were to do the project here, would probably take about an hour. It took me about an hour yesterday to work out the point-to-points and the mesh links in that particular case. But I want to take and move on here. So now we've got hubs. Ultimately, you'll end up with azimuths on the V5000s that work for the multi-point. So now I'm going to take and add the subscribers to this and see how many subscribers that I can actually connect. So I go back down to my my project and I go use my best server analysis. And this is really what I want to show at this point. So my group, I'm going to use primary one as my group. I'm going to take and make sure, again, that the target SM mode is BPSK, is a minimum link. I want to be more than a minimum link. So let's go up to MCS6. I'm going to make it QPSK, and I'm going to add a couple of dB of margin to this. I'm going to use the site maximum height above ground. And I'm going to say you can choose V1000s or V3000s. So I have 108 subscribers that I've got plotted on the map at this very moment. I'm going to press go. I'm not sure how long I'll leave this go, but sometimes this takes a little bit. So it's requesting profiles from LinkPlanner Mama, and so I'm going to take and do some testing. So right away, I've got 10 of them that are out of range. OOR means out of range. NMR means not meeting requirements. So as I go through this, if there are links that are too long, that do not meet my minimum capacity or my mean capacity requirements, they will be listed as NMR. And then I can take a look and see why those links are NMR after we've taken and created a few here. So this process, it takes a bit. It goes at the speed that it goes. I did this whole project in this town is actually about 400 or 380 or something like that subscribers over the town, and it took about 60 minutes in order to run through this process. But what I was able to come up with when I was finished was a list of sites that should be V1000, should be V3000, and ultimately, as we were talking before, we ended up with a bill of materials that shows the connection. So if I go here to the other project, I think I can move. I think I can go. Okay, so let's go here. Let's turn on the multi-point links and the subscribers. All right, so here's all the azimuths that I ended up with. They'll be all listed when you do an installation report or a project report here. The azimuths of the V5000s will be noted, and you can see here that the links that it thought were the best here to connect to HDN. So I have a matrix of CNs to DNs that I have here. And as I go down here to my bill of materials on this particular project, I have a complete list of what I need for the point-to-points. So it says here that I need 12 V3000s that I'm using for point-to-points on this project. I am using for the point-to-multipoint, the hubs first. We're doing 12 V5000 distribution nodes, and then as we get down to the connection nodes down here, you can see that I've got 103 V1000s, and the tool here, LinkPlanner, said that I should be using 5 V3000s on this particular network. So this takes a whole bunch of question out of whether I can, whether this is going to, I can justify building this network or not. Do I want to do this? So here's the bill of materials. This would be what you just export to a workbook. Let me do that. And so then this is the workbook that LinkPlanner produces. So my full BOM, there's the complete list, complete all the accessories that I need, plus any notes that are there. If I go back to my index, I can see that I've got the multipoint network. Click on that. There it is there. And there's my subscriber list, my 103 subscriber V1000s and 5 V3000s. And so then you just send that off to Dale or Brent, and we'll price that for you. So then also here I've got a list of the bill of materials, I should say, for each one of the links individually. So it does a nice job of breaking this out. If there's something in here that I want to change, for example, maybe a POE or something like that, well, then I can do that from here. I can say, no, I don't want that one, I want this one, or whatever the case happens to be. So let me put that back to bed. All right, so now let's go back up here to this best server analysis. Let's see what's happened here. All right, so he says right now that I have 10 out of range. I'm able to connect 78, and I'm still testing. Okay. And he's going to be done soon. All right, so there it is. All right, so now I have there's my outer range. The ones are labeled pink here. I don't have any that are not meeting requirements that can connect, but I've got what I've got here is I've got what the best serving sector is, which is AP1, and it tells me what I should be using there. So there's this connection node 130 should be a V3000, for example. 184 here should be a V3000, and I've got the second best serving sector, and then the third best serving sector, and you can tell that by the list. They're a little bit. There's when the second best serving sector isn't good enough, it leaves it blank. When the third best serving sector doesn't have a sector that connection that meets the requirements, then it leaves it blank as well. So if I press create here, what I do is I connect all my best serving sectors. Then, so let me do that. So it's creating the links. All right. And then, so let's go back to the map now. And in the map, there we have the links that we've just created here. So I'll bet that's a V3000. I bet you a couple of these are, because I did not put hubs at node 20 and node 18, and so there we have you know, this network at this particular point in time. I can go to the multipoint links, and there's the summary of them all. There's the mesh links that I have that are working, and it gives me the details of that. I have the access points that are here, and oops. Okay, and number of subscribers is higher than can be supported by this sector, so it labeled it red. So that means that I need to probably find another place for another DN, although this is likely on that northwest edge or northeast edge. So if I applied another DN to the network, I could probably relieve these errors, but it tells me that I got more than 13, so that's okay. So anyway, that is the essence of how to plan the first level of a cnWave project. Now, if I were to justify this and say, yes, it's okay, I want to do this, and it was any more than, you know, just this few sites is pretty easy. But you can see where this would be a valuable exercise to do if I wanted to take and for example, do this whole area. Oops, I'll go the other way. So the whole area. So here's our little town, Grand Cache happens to be, and their DN locations all the way from the west end of town here all the way to the northwest to the southeast, or I should say northeast to southwest section of town here. Get the directions right. And anyways, if I wanted to do that, is that worth? At this point, I could take and generate a preliminary bill of materials. I would get some preliminary performance numbers. If I were to take this, I would probably drive back to Grand Cache here to do a site survey, and I would say, can I actually accomplish this, or is there something else that I have to do to be able to take and make this? Which of these CNs cannot possibly connect to the DN that I've specified here? And so that's one way here to take and manage your mesh. So I hope this was valuable. We've taken 55 minutes here. Are there any questions? Nicole, are there any questions? Anybody else ask anything during the presentation here? I'd be happy to answer.
Nothing as of yet, just Eldon's question that we already answered, but I will give everyone a couple more minutes in case they did have something come up from that live demo.
Okay. All right. I'm trying to think of what else to talk about. So the azimuth is very important. The azimuth of the V5000 is very important. It's okay to start with them all in the same direction on the template, and the more that we can keep in the same direction, the better it is. If I took and built the CN connections with the azimuths the way that they are now, and or the way where they're plotted from the template, I could probably connect all the CNs. Then when I go to do the meshes, if I do the meshes after I've taken and connected the CNs, this becomes messy, because if I take and reorient a V5000, I've got to take and rerun the best serving sector in order to take and reconnect some of them that are going to be disconnected. And so this is the right order. The right order to do it in is to lay the sites down. Just summarize: import the sites, import the subscriber locations, create the hubs with the template, the point-to-point and point-to-multipoint template, create those, create the hubs with the multi-point template, then take and do the mesh, then take and connect the parts of the network together with point-to-points that you need to take and expand that coverage. And if we go down here, let me just point out a couple other things here that when I was finished yesterday, the Tech Talk project, there we go. Okay, so let me blow this up a little bit and let me get rid of the access points and the subscriber, Multipoint Links. Okay, all right, so there I have some subscribers. Let me blow this up again a little bit. All right, so I've got the fine lines here. The fine green lines here are V5000s that we're able to mesh. So on the edge of the network here, I've got 19, 17, and 18 that we're able to mesh together. I've got 26, 27, and 24 that we're able to mesh together, actually down to 23. 22 can mesh together with the orientation right, and 22 can connect back to 28. So what I've got here is I've got a ring right here. And so the CNs that connect to that ring, if something were to happen to one of the DNs, then the other ones are still in. It's not a serial connection. I have another ring that I created here between 28, 21, 20, and 25. And so that's a closed ring right there. I also have another closed ring between 20, 19, 17, 18, and 21. So that's another closed ring. So if anything were to happen to an individual DN out here, I'm not, my whole network isn't in this end of the network isn't down. It's just I'm going to lose the clients that are connected to that particular DN. So it's really important. It's really important that we build this in a ring topology, if at all possible. If not, linear is fine. We have to make sure that we have good link quality. But in this case, I managed to build a few rings, and so that's kind of the goal of this. Then I would take and go, back out to Grand Cache, and I would see, can I accomplish this? And take it from the project report. I can export the project report here and the installation report. I've got all the data that I need for looking at all of this, and then I can decide what I need to do. So maybe there's some trees or something in a way here. Let's put the Multipoint Links back up just for a moment. All right. So maybe there's trees or something here, and I can't reach there. So I've got to take and maybe move some from 18 to 17, or maybe I got to move some from 21 here to 20, or things like that. That's the tweaking that we need to do when we actually build the network. But at least what we have here is we have a plan, and we have a bill of materials, a preliminary bill of materials, so that we can take and add up what we need to do for this particular project. If there are no questions, that's what I had today.
Thank you, Dave. This was incredible. No other questions did come in the chat, but I have a sneaking suspicion that once people get in and start building their own, they're going to have questions. So be prepared for outreach.
You bet. Anytime. Send questions, send comments to marketing at. Let me just put that back up again. We're here. I think I can do it from here. There we go. Marketing at mbsiwave.com, and we'll be happy to take your feedback, your comments, your suggestions, your requests, whatever it is. We're happy to hear from you.
Thank you, Dave. Looking forward to the next one.
Thanks very much. See you later.